This is Mrs. O'Neill for AP Chemistry, Chapter 17, Section 5, Factors that Affect Solubility. You're going to investigate those factors, especially the common ion effect and how they affect of acids. So the three factors that affect solubility are the presence of those common ions, pH, and complex ions. So pause, play it, fill in the words, and then play to hear mine. If we tried to dissolve a solid in a solution with either of those cations or anions being already the common ion, they're already present in the solvent, of course less of that solid is going to dissolve. Again, we have to think about Le Chatelier's principle and that shift in equilibrium. So in other words, the solubility of a salt is much lower in a solvent that already contains one of those solute ions. So again, if there's a common ion, there's going to be less that can dissolve. When we talk about solubility in pH, we have to think about OH negative, our hydroxide ion, can also be considered a common ion. And of course, they're going to be more soluble in acid because it's going to be a neutralization reaction. So if we have something like magnesium hydroxide reacting with something already in solution in an acid, of course, it's going to be a neutralization reaction and it's going to shift into ions more. For other anions, maybe ones that come from a weak acid, they are more soluble in acidic solutions. So if we take something like calcium oxalate and we break it up into its ions, and now that oxalate ion can actually react with the H plus ions from an acid and make more weak, this is your conjugate base there. So it will just be more soluble again in acidic solution than in maybe a normal water solution. So what does this mean? Let's take a little bit closer attention to this. So if we have lead 2 fluoride, we have lead 2 fluoride in its solution, just hanging out. What's going to happen if we add H plus ions to it to try to make it acidic? Well, that H plus is going to actually react with the F minus to make weak acid. So we're going to decrease our F negative ions, and we're going to increase the Pb plus 2 ions. So what's going to happen is we're going to increase that solubility. We're going to take a chunk of solid and we're going to make more ions. So we're going to increase the solubility, but this also pH is going to decrease because now we're going to have more weak acid in there. So if we look at it the other way, something like PbI2 or lead 2 iodide, here we have lead 2 iodide, the H plus, when we add it to solution, nothing's going to happen. Nothing's going to happen here because there's, remember the HI that it would potentially make would actually be a strong acid, and therefore there's not going to be a reaction. They just stay in ions. So again, if we look here, if we have H plus to something that we can make a weak acid, we are going to increase the solubility. But here, the solubility of adding something like a strong acid is not going to affect because the HI is also a strong acid, and so we're just going to keep ions in solution. So what are these complex ions? First of all, I want to tell you that the only place I've seen complex ions on the AP exam has been in, let's say, a reaction. And I want you to read that last line there. Treat it as a regular reactant or a product in your reaction. They have never asked specific questions about a complex ion, but they want you to be able to recognize a complex ions. So remember to read as you write, as you filled in those blanks, and hopefully this information makes sense. So here I want to just show you how a complex ion is really a metal ion surrounded by other ions or molecules or other polyatomic ions. And again, they do have their shapes, but I wouldn't go crazy there. But they kind of look funny, right? They have the metal, and instead of just a regular ion, it's a polyatomic ion, and then that whole thing itself is called that complex ion. It's just complex, right? It's a little bit more complex than a normal polyatomic ion. So again, how do we, if we add this ligand to our equilibrium, again, the ligand is usually in large excess. The individual Ks were also going to be large. So again, we're going to treat them as if they go to completion. So we're going to treat the formation of these complex ions as if they go to completion. And of course, this is going to be the biggest ions in solution. So if we look back at these pictures, they look humongous, and they are big in solution. So we just want to make sure that you understand that they take a lot of room. So again, if we do, this is a common complex ion, this silver with this complex ion, however you want to say that. So again, if you want to pause the video and kind of look at this information and look at the pictorials, just to give you an idea of what actually happens and how they form. But again, what I want you to understand is if you see a reaction like this, yes, this is a complex ion because it's something you've never seen before. It has a metal. That's one thing to remember or to look for, that it has a metal and you have attachments or those ligands attached to that metal. And then we're going to just treat this as a normal ion or a normal product in this reaction. So again, here's a whole list of, here's your, again, just kind of look over this and make sure you're understanding what those complex ions would look like. Here's our equilibrium expressions, and here's our K constants. And look how huge they are. They are enormous. So they basically go to completion more than even be in equilibrium. But I just want you to get that visual of what these look like. Amphoterism, metal oxides and metal hydroxides are insoluble in water, but they will dissolve in a strong acid or a strong base. These solutions will then behave as acidic or basic themselves. So we just want to know that some of those metallic oxides and metallic hydroxides, just like we've seen before, the magnesium hydroxide is insoluble in water, and that's why they precipitate out. So again, here we have something like aluminum hydroxide. Again, it would be a precipitate. What happens if it reacts with hydrogen, a strong acid? It will dissolve, and if it dissolves, it will also dissolve in hydroxide. It will also dissolve in a base, making that complex ion. So that's what this was really trying to get you to understand. So if we take something like aluminum hydroxide, it can react with the H+, dissolving, and it can also react with OH, making that complex ion. Either way, you form a new stuff. Okay, we will see you in class.